Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel where we talk about everything I want to, science and math. And today we are doing physics, and we're talking about mirrors. Woo! All right, so this is going to be a little bit difficult because you're not here in front of me with your book right there where I can point to the pictures. So we're going to get through it though. We're going to make two videos. I'm going to be doing one that is, I'll just sort of talk through some of the concepts, and then the second video come back, I'll show you the pictures a little bit closer, and you'll be able to do the math. I'll have a close-up on the math. All right, so mirrors. We talked about last time with light that something is reflective if it is extremely smooth. So if I feel in my mirror, it's very smooth. And also, in addition, there are certain elements that have reflective properties. And in chemistry, we talk about things that have free electrons, that they are the ones that are more reflective. So they silver the back of mirrors. It's not always real silver. Sometimes now it's things like mylar. But they silver the back of mirrors, and then you have two different parts of this reflection. You have the smooth nature of the mirror and the reflexive nature of the silver in the back. So you can see outside, and it was snowing out there. You might see some snow in that reflection. Okay, so this is our plain mirror. It's flat. The light bounces back. Now when I look in that mirror, it looks like it's deep, like I could reach in there and it would be a distance before I could touch my face. It's not like my face looks like it's right on the mirror. The reason why is because we have two distances. We have d sub O, which is the distance between the object and the mirror, and then we have d sub I, what appears to be the distance between the mirror and the object, and they're equal to each other. I look like my face is the same distance from the mirror here as it is in Alice in Wonder Through the Looking Glass Land. So now the other thing is, the way the light bounces back is it doesn't bounce just straight back. My eye is here, but I can see, like, down to my shirt and stuff too. And it's because that it appears that the light that is coming off the object is going straight. And by what I mean is I can see my shoes by looking down into the mirror, and I can see the image of my shoes. I look straight in the mirror, I see the image of my eye. And it's these virtual lines line up, which you're going to be able to see very clearly as you look in your book. Now, the other thing is, what about if it's not flat? So I've got my spoon here to show you this. Remember in math how we talk so much about parabolas? Well, this is a parabolic, a curved mirror here, my shiny spoon that I got. And it is going to act differently if I'm looking at the back side or the inside. This is a convex mirror. This is a concave mirror. It's caved in. Here the light bounces in, and then it bounces together and is focused. There's a focal point. Here the light bounces off and it goes in all directions. So I want you to pause the video and go get yourself a spoon. All right, I'll wait. Okay, you're back now. You hit go again and you've got a spoon, right? I want you to take your spoon and look at the back side of it. And what do you see? You see yourself a little distorted, right side up, correct? So, and not only that, you can see far around. You have a real good range of vision, because as it's curved, I can see where I am. I can see way over there. I can see way back over here because of this curved surface. On the inside, now flip over and look at it, and what do you see? You see yourself upside down, right? And little. But now what I want you to do is I want you to bring the spoon closer and closer and closer to your eye. Close your other eye and see what happens if you put it all the way up to your eye. What do you see? You see your eye huge and right side up. Do it again, blink, make sure you understand that your eye is right side up, and you can see your eye big and right side up. What we have done is we have gone, first we started outside the focal length, and the light bounces off and flips. Then we moved inside the focal point, and there we were seeing it magnify it and not flip it. So you can look at some pictures in your book. They show you the lines of the light so you can understand that. We're going to look at the math that goes with that in the next video. Okay, and now, so this is our mirrors. The same thing pretty much happens with lenses. But instead of the light bouncing off, it passes through. Excuse me. I can't breathe and drink. I need another drink of water, sorry. The other thing, lenses like mirrors can be concave where they go in, or convex where they're fat. So concave, convex. And that is whether or not with your corrective lenses, whether you're nearsighted or farsighted. So people who are nearsighted have concave lenses. People who are farsighted, have convex lenses. And the reason why is your eyeball is misshaped. If you are nearsighted, meaning you can see near but you can't see far, your eyeball is shaped like a grape going this way. If is the other way where you can see far but you can't see near, then your eyeball is taller than it is long. If your eyeball is nearsighted, where it's like a grape going this way, the image isn't making it to the back. The image is focused here, and the back of your eyeball is where it needs to be focused, so the lens will correct it and put it there. The other one, if your eyeball's like this, the image is being formed like, if it could, back here in your brain somewhere. And the glasses, once again, make it focus on the back of your eyeball. And you're going to look at the parts of the eyeball. All right, that is it for this chapter. The main thing we need to do is go back and look at the math, and you need to go look at those diagrams and make sure that you understand how the light is bouncing off and where it seems to be coming from. All right, like, share, subscribe. Come back next time, and we will talk about more about light.